Hello, welcome to Math 1324. This is Chapter 5, Section 3, Example 1. And in this one, we're going to go ahead and look at the present value of an annuity. Now, what do we mean by present value? All we mean by present value is basically, given some annuity that you're creating, how much would it take instead to put into a bank today and then just leave it there using compound interest for that amount that compounds in that same amount of time as the annuity to have the future value of the annuity equal that future value using compound interest. That's what we want to know. So to do that, okay, so I've talked about future values of compound interest and just the annuities. Let's look at those formulas. So for the compound interest, the formula is P times 1 plus R over N to the N times T. And for annuities, it is A equals capital R times 1 plus R over N, all in parentheses, to the N times T, minus 1 all over R over N. Good. Okay, so basically what I want to know is, when is this equal to this? That's really the question. So let's see what happens if we set those equal to each other. P times 1 plus R over N to the N times T should equal capital R times 1 plus R over N to the N times T minus 1 all over R over N. Good. But notice all I want to do is get the P by itself. I want to know what is that present value, or the principal, in other words, from what you saw up here. So I need to divide by 1 plus R over N to the N times T. But the same thing as dividing by that is the same thing as multiplying by the reciprocal. So I'm going to multiply both sides here by 1 over 1 plus R over N to the N times T. And notice that this and that cancel, and we still have this over here. And I'm going to go ahead and tell you, I'm going to use this little trick of moving this from the denominator to the numerator by introducing a negative in front of that exponent. So our new equation will look like this. So we still have the R, and then times all of this. And then times, instead of what you see there, it's going to look like this. 1 plus R over N to the negative NT. So all I'm going to do is distribute this to the numerator, because this is technically over 1, so I need to distribute to the numerator here. And that's going to give me P is equal to R, and then 1 plus R over N to the N times T times 1 plus R over N to the negative N times T. Notice that the base is 1 plus R over N. The exponents are nt and negative nt. If we add those together, nt plus a negative nt, or in other words, nt minus nt, that's just 0. But remember, anything to the 0 power is going to be 1. So all I'm left with here is a 1, and then we still have our minus from this. And then 1 times anything is that anything. So we're going to have the 1 plus r over n to the negative nt all over R over N. And there you go. There is your formula. This is the present value of an annuity. Good deal. There's the entire work. I'll see you in the next video. Have fun.